How's it going, everyone? Welcome, Elier Gonzalez here. So, in today's video, I do want to make a quick recap of this data fetching section, which is part of the model of the joy of React, a course taught by Josh Camilla, a software engineer that previously worked at Khan Academy, one of the first companies to use React at scale. And so over the couple days and weeks and series of videos, I went through the several of these sections to describe how do I get here, particularly with React. So again, in today's video, I'm gonna make that quick recap, which is something that I usually do in all of this series of videos. As a way to describe is this process, and if you have to explain, or in my case, I find the need to explain that to other audience and other people, is, hey, what is React, right? So this is part of the sales pitch, and it also is to improve my communication skills as I figured it out what this tool came from, what allowed me to do, what problems does it solve, and in which situations are useful and others don't. So the TLDR of this is, right now we are on the model 3, as you can see here, on the React hood. But in the couple models, at least in the model 1, we went through the history of React. The TLDR of this is Facebook has a particular problem to manage their piece of information that is shared across different UI, particularly on the chat application, when they have now the message icon, the message drawer, right? This nice little chat box where they create to highlight is who is connected or not, and then the main chat applications. Because the way how you build these kind of applications is you have the model view controller, where the model described is what is the data that is going to be used by the view and pass some data treatments via the controllers, and allow the controllers to decide, hey, which user can have access to this page or not, part of the routing, okay? So the problem was you have to have independent UIs or model view controller for each one of those components, which if they share a piece of information, so you have to update that in different files. So this can become quite cumbersome for Facebook because the more a piece of information is shared across different realms or different UIs, you have to also update on each one of those places. So the R&D at Facebook back in 2009, they created this particular tool that say, hey, let's going to now have as one single source of truth, and this tool is going to update the UI accordingly. So anytime that this piece of information change, whatever UI that uses that state, and when that changes, is going to reflect those changes. So that's the premise of React. This is on the web. This has been so powerful, this idea, that it also migrate to the mobile ecosystem with React Native, right? It sounds like a good idea, but it turns out that it introduces a lot of complexity. The TLDR for Facebook is that they want to write once and deploy everywhere, right? And also you can use React for the 3GL on the web. So in order to understand this tool, we look at what the React is on the web, how you can import that, what is the anatomy of this React, which is attaching this element to a specific HTML DOM, usually with an idea of a root. And then you are going to describe how the look like will look like. How so? By using the create elements, which is a function provided by React. And in there, well, you specify is the HTML tag or the tag that it can be whatever name you want to, right? Also the props that this accept to, the attributes and the data that you want to pass to this element, as well as the children's elements. So when you execute this, right, React give you now is a JSON that describe is the particular state of that UI of that React elements, and it is a state, as well as additional properties here. So this internal representation in a JSON-like object is what they mentioned that React is descriptive. So React is allow you to describe is the UI. So the only reason to get that is if you actually has hands-on experience on that. So because of this way of creating applications, right, it can be quite tedious to do so. The community come up and say, hey, because at the end of the day, we are now calling this create elements from React the library, and it is where we can describe all of the UIs. Wouldn't it be nice to have is a markdown that combine is the logic, JavaScript, and the markdown? Now this is why GSX kicks in. And also we look at the subtle difference between GSX, for example, with attributes, how you define the attributes, how you define the events, how you have some specific keywords for class name or for, and also the why gotchas in React, right? The fragment, which is a component from React that allows you to render a series of elements without having a parent component to declare or to avoid populating unnecessary the DOM, avoid DOM pollution. And also, how can we now is starting to build these applications here. So the paradigm shift, because now we're not only working with HTML, CSS, and JavaScript, we're also working on a layer on top of JS, which is React, right? And this has a particular way to build this kind of applications. So this is where you have is the entry point, which is the index. This is when you use, for example, create root to actually attach your entire applications into the DOM, onto that particular DOM element in the index.html. Then you have the, also you define here is like CSS styles, for example. And then you also have the app home base, which is the React powerhouse. This is when you do app related stuff. For example, defining the providers, which is just a fancy way to say, hey, let's going to provide on the React context app is this piece of information. It's going to provide this, for example, CSS transitions or the themes or the some app level data, let's say like users or settings, also the navigation. Hey, this is how you can have access to these objects that allow you to navigate in these client-side applications, and among other stuff. So this is the general project overview. And when you want to do common stuff on the web, like rendering a list of elements or conditionally rendering elements, so the nice thing is that unlike other templated language, like Blade from PHP, or the Ruby. I don't recall what the Ruby is. Which Shopify use that. Liquid, right? All of these templated language have their own particular mini language to define basic JavaScript operations or basic UI operations, right? Like, hey, how can I conditionally rendering elements or rendering a list of elements, right? So in JavaScript or in React, you can leverage the existing array methods for rendering elements. How also with, for example, map operations, map, filter, or find, and also when you do want to attach some key to these elements, so React can uniquely identify them, you can do that. Whether it's this is why it is not recommended to render elements or not rely on the index, because if the index change, let's say you're now removing elements in that collection and then you add new ones, so then you have now inconsistency on how React is keep tracking of these elements uniquely. So an alternative to, well, always relies on an external key, whether it's come from the database or whether it is auto-generated by math.random, or more likely the crypto.random get UUID. Get random UUID methods from Crypto Web API. So that's great, all right? And when you want to conditionally rendering elements, whether you go with if statements or and or the ternary operator, which is, hey, I do want to show is an if, like an if else statement. There's some gotchas using this. For example, the falsy values. This is why it is preferred when doing this conditionally rendering using ampersand, is to coerce that value into a boolean, right? And also how we can add CSS to our components, particularly using is the CSS in modules, right? So on that, right, and how actually CSS model works behind the scenes, by attaching now the name of the component and another prefix to the CSS rule name that you define on the CSS. That actually is now true scoping, because you have a particularly CSS rule, CSS name rule attached to that component. So this is just the model 1. And on the model 2, I'm gonna speed up things a little bit, which is looking at how can we provide interactivity to our applications, how traditionally we did this with HTML, CSS, and JavaScript, particularly with HTML or with JavaScript. With HTML is by attaching or calling a functions directly in this HTML markdown, or by attaching an event listener via the JavaScript programmatically. But in the case of React, we don't do that. We just pass a reference to these event handlers at the HTML element or at the React element, and it's up to React to call that function for us. So this particular mechanism is something that software engineers like Martin Fowler mentioned. When you call your functions, this is known as a library. When your function gets called, this is known as a framework. And since we live in the era of abstractions, right? Software engineering actually live in this, I will argue that from 60, right? We live in this era of abstractions. So now we are not directly calling our functions. Our functions get called for us. And in the context of event is when the user triggers something, right? And you can take a look now at the user event page. So I can make a quick let me do that real quick. On the user events and MDN, right? Not on the UI event, but all events. Web APIs, yeah, events. You don't have like event source. Yeah, this is the interface, exactly. But this is event source. Server send event, no, event. That's right. This object here, right? And an event can be triggered by user actions, whether it's clicking the mouse or tapping the keyword, or generated by API to represent the progress of an asynchronous task, right? But this is actually what an event is. It can be group. It can also be triggered programmatically, such as by calling the HTML click methods of an element, or by defining the events and then sending it to a specific target using event target dispatch event. There are many types of events, some of which use other interface based on the main event. An event itself contains a property and method which are common to all events. But again, here the MDN docs is saying, hey, this is an event can be triggered, and this represents actually this interface represents an event which takes place on the event target, right? And again, all of these are DOM events, document objects models. Interface that is implemented by objects that can receive events and may have listeners or not. In other words, any target or event implements the tree method associated with this interface. I just want to show you what are the events here, or at least this event what can represent. But as you can see, since this is a DOM event, it can be either is a user event, whether it's a click mouse or tapping keyboards or generating APIs or generated by your APIs to represent is the progress of an asynchronous task. So it can be is user generated or programs generated, right? So this is the distinction here on this event, at least on the DOM, which is what we care about here. Hey, what is the kind of events that we can have here? Who triggers this? It was a user, or it was a program, okay? Or it was a program based on an event or an asynchronous task. But that's the whole idea of these events. So because event has a particular since the browser has a mechanism for detecting this event known as the event bubbling. So we have seen that a web page is composed of elements. For example, a heading, paragraph, articles, text, image, buttons, and so on, right? And that you can listen for events that happen to these elements. For example, you can add a listener to a button and it will run when the user clicks the button, right? But this is event bubbling here. We have also seen that these events can be nested inside of each other. So for example, a button could be placed inside of a div. And in this case, we have called this div elements a parent element, and the bottom a child element. In this chapter, we'll look at the event bubbling. This is part of the core models. They say that this is the dynamic scripting with JavaScript. All right. I do find this quite interesting to look at this, at least to have a quick overview of how the things work. So this is part of the event. Events are things that happen in the system you are programming, which the system tells you about, so your code can run here. Exactly. What is an event? Events are things that happen in the system you are programming. The system produces or fire a signal of some kind when events occur and provide a mechanism by which action can be. In other words, an event can be summarized as by a piece of program, by a piece of code, by a system, or by the user. That's what event is. Is things that happens when a piece of programs or a user triggers that, right? So that's what an event is. And I mentioned this because I want to speed up things fairly quickly. To why we have is this event bubbling, and the whole point of this is to determine which event actually is going to trigger that, right? So learning outcome is the event delegation achieved via event bubbling or event capture, stopping event delegation with stop propagation, and accessing event targets from the event objects, right? Let me see if they here describe what is an event exactly. Exactly. Again, events are not unique to JavaScript. Most programming languages have some kind of event model for that. Exactly. For example, the Node HTTP Connect event docs provide a good example. Exactly. The Node, among others, right? For example, in the preventing default behavior. So in this chapter, we have learned what events are, how to listen to an event, and how to respond to them. You have seen by now that elements in the web page can nest inside other elements. And for example, in the preventing default behavior example, we have some text boxes placed inside of div elements, which in turn are placed inside of a form elements. What happens when a click event listener is attached to the form elements and the user click inside one of the text boxes? The associate handler function is still fired via a process called event bubbling, which is covered in the next lesson, which is describing this. But an event bubbling happens when you add an event listener to a parent element, and then the user click the child element. Why this is important? Because again, all the discussion is from the model 2 here. Well, model 2. Let me go to model 2, right? On model 2, to describe about that events are handled, how the HTML, traditionally CSS, and JavaScript works, right? Whether it's by trigger that event on the HTML or programmatically by attaching an event listener, and what happens when you do that programmatically, which is trigger an event bubbling. So if you have now, which is happening also in HTML and in JavaScript. So if you have now particular elements that if you have a form inside of that, you have now an element, right? So the on click is going to bubble in that. In other words, any elements that have an on click, it will run that code above them. But again, this is particularly designed to actually kind of make it cheap for events to run. Or in other words, is to run all the events in one run. So yeah, I don't want to get lost into the detail there because that's not what the today video is all about. It's just that after I describe the event handlers and the way how we do that on React, then is the how you can provide interactivity to these components using is a particular hooks, the useState. This allows us to store some piece of information, primitive or complex data, for example, like functions and objects and arrays. And what happened when you update the state here inside of a event handler. So React is going to now pass through the core loop, which is made of two scenarios. In which a scenario is going to run this? I am on the initial load, all right? If it is, what I'm gonna do, or React, is appending all of these elements into the DOM. So the DOM or the browser can render that, right? By passing through the critical rendering pass. If it's not, then which is on the scenario 2 on re-rendering, it's a who triggered this state update. This is part of the trigger phase, and it go to that function. React is gonna run that function, which is at the end of the day is a JavaScript function. And if that JavaScript function return additional components, it will continue to call them until there is no more components to call, right? So on each one of those calls or rendering phase is gonna recreate, or is gonna create now a snapshot or the JSON object in for this new version of the UI that should look like. This is known as this new snapshot here. So now this new snapshot contains, so once that is done, it's going to React commit those changes to the DOM. How it's gonna do that? Through the diffing algorithm. But it turns out that it's going to take that piece of, or it's gonna update only those property that has changed for, and then apply that to the DOM. When that happens, the browser detect those changes and then update the UI to match the and then update the UI to match, and then so when the browser detects those changes, so when the browser detects those changes, it's gonna repaint to match that UI, right? And this process happens over and over anytime that you update the state using the useState. And there's some gotchas here, because this state updates or this rendering is asynchronous. It's going to happen on the next tick, right? And the notion is of what is rendering and painting, at least for the web, all right? So another common thing we do in React or building web interface is to build forms. And how do we do that in React, right? So we can use now a form, and then on the legend and define is the several inputs that we need to collect from the user, whether it's input text, email, or password, or input select, or radio buttons and checkboxes. So because each one of those inputs from HTML, they don't have a unified way to update the value and then get the value out of this. React create now an interface, a common interface, at least for the inputs and the select and the context area. But for the radio buttons and checkboxes, it has a particular one. where the idea is to update the check property here when something happens. So all of this is just for briefly describe is the form sections, how you do this data binding, or you can also pass props in props versus a state, right? Or you can work with complex state by defining is whether if you pass a function and what happens when you pass a function. This will only gonna run when the component is mounted, right? Only once, or if you pass now an array, or if you pass now an object, and how you should always return is a new state of that, right? The reason behind that go beyond the scope of today's video, but the TLDR is part of the functional programming when you want to regenerate is a new state instead of mutating the data, right? Additionally, or you can dynamically generate when you're rendering a list of elements, something that I mentioned before, right? And where you put your states matter, because that will indicate to React that from this point on, I'm going to render this, or in other words, I'm going to call all of these React components, right? And that's critical. As you're starting to create now more and more ambitious applications, whether it's client-side applications or simple websites like a blog, or like a blog or a landing page, or if you want to build a heavy client applications like trading app, or like trading app, or how do you put it, or gaming applications, right? When you somehow need to have a way to keep track of all of those state change, known as the state management, whether it's Redux or Recoil or Substance, and how also is useful for us to when you build now server-side applications like back office or SaaS or reporting tools, that kind of stuff. The challenge there are quite different, because now the state live is outside of the client, is on the server, and you have different set of problems. Whether it is, hey, how can I make sure that I get the right data at the right time? How can I catch the response of that data? How can I make sure that that data doesn't grow stale at the client side? In other words, I need to revalidate somehow. How can I prevent myself to firing too much requests, or to cancel, or to be preemptive by canceling or firing network requests based on some user hints, and paginate those results. So this is the kind of problems that is related to the state management here, and also the notion to develop the notion of components instance and the rendering here, which is in module 3 something that we are deeply looking at. That say is, once we know the basics of React and how to build this small user interface, as your application grows in complexity and then you need to add more piece of information to your components, to your application, let's say, hey, now I want to detect when the user mouse, when the user move mouse, or when it resizes the window, or when it passed through a certain point in the document via the interception observer, or I want to provide a feedback, or I want to detect is if an audio tag is playing or not, or if a video, And when you entering in this particular realm, when you need to keep track is this piece of information, the only tool that we have available back then in React 17 was components. So we overuse components in other places. So the community and the React team say, hey, it'll be useful for us to have now is a particular file that describes is this app level behaviors, known as the hooks and custom hooks. So React give you common hooks to work with, and you can create your own hooks as well. There are some rules of these hooks from provided by React that they must be at the top of your component, and you cannot nest it inside of any conditions or for loop, right? And yeah, that's part of the rule of hooks. So the first hooks that I looked was the useId hooks to say, hey, sometimes when you need to have a global registry or a global identifiers, useId is useful for this. When is a use case? So for example, on forms, right? So you want to now provide a unique global identifier to your name or ID in those inputs, right? It's an input text or a select or radio buttons or radio buttons, how do you put it? Radio button checkboxes. So that's particularly useful. That's where that hook is useful. Another is a useRef. So sometimes you need to grab a DOM element so you can interact with it. All right. So for example, hey, I want to focus the attention on this element when it's rendered on that input. For example, I do want to grab is a video tag or a video or an image or an audio tag, right? To do so, and this is what these hooks allow you to do. So let me grab these elements. I don't want to be part of the rendering. I just want to is sync now. For example, is the state that live outside of the React into my React app. So when I mention that, it also opens up another hooks known as the useEffect. So anytime that you need to synchronize with an external system, or in other words, you need to is at the UI level listen for global events or for data that come from a server or from timers, right? All of this piece of information that live outside of our applications that is being tracked by those systems, and then we need to hook into that or synchronize our state with them. That's when you use now a useEffect. And useEffect has an anatomy. So whether if you pass now a callback function, and this callback function is describe what is the synchronization process will look like, right? And also how the cleanup function is, or what you want to do after this component is mounted. And the array of dependency, aka when do you want to kick off this particular script? This script, by the way, runs after every render. So the idea here is that when that happens, all right, you want to know when and how, when you want to know when to synchronize your React app with this external store, whether it is when the component's mounted, all right, or when any of these elements change, right? And this is what the use effect is all about. So if you don't provide anything at the second parameter, this effects will run after every renders. If you provide now an empty array, you are telling to React, hey, only run this script after the initial render. If you provide now an array of dependency, hey, I do want you to run this script after or when each one of those depths change. So that's the whole point of this. And I look at an example of how to actually do that. So for example, hey, I do want to now detect when the user hit spacebar for pausing or what it is, for pausing or playing an audio player, okay? So because I do need to listen to a particular event that will happen is at some point, right? And then now update that state. This is why I look now at the exercise here with running on mount, running or kick off this script on mount, kick off this script when it's unmounted, and what is the life cycle of this particular hook, which is when it's mounted, it's going to kick off the effect, and now when it's mounted, when the component is mounted, it's gonna run out the kick off the effect, right? And when this component is re-rendered, it's gonna run the cleanup functions and then the effect, and so on and so forth. And when this component is unmounted, it's going to now run the cleanup function. So this is the cycle here, the life cycle of this effect, and how sometimes it's useful for us to understand that inside of this hook, you can pull data out of this, whether it's from the components instance using the state setter callback, right, provided by this function on the useState, or by reading is directly that state that you provide and the array of dependency. So also a quick note on the strict mode, which from React 19 it say, hey, let's go to actually let's go so React in React 19 strict mode summarize two stuff. One is the summarize two stuff. One is or you can summarize the features of a strict mode in two things. Is help you to avoid common gotchas, especially with useEffect, right? Which is something that we can take a look at this. Exactly. Safeguard designs to amplify potential issues, and warning about deprecating APIs. Okay, makes sense. That's very interesting. That's very interesting. Hey, this feature that you're gonna use, we're going to deprecate that in next feature. So make sure to align with it. I think that's very powerful here. Most of the time, because you end up building this kind of web app in React, right? In that particular version, and then you have to ditch that after a couple years, because it is completely different. It's so completely different that that you'll have to rewrite this entire app again. And that to me is part of the nature of how things are in the realm of the web, particularly React. But you have to guarantee backward compatibility, which is something that JavaScript have to do. Otherwise, it will break a lot of things on the web. It turns out that it has done that. But in any case, so once I look at that, right? And yeah, mentioned here about the rule of hooks, right? So hook has been called within the React scope and at the top components. So once I look at the side effects here and what these side effects allow us to do and what this particularly custom or hooks provided by React give us to us is, to summarize, is an app level behavior. This is why these custom hooks are so powerful. Because, hey, if you, for example, want to run, let's say for simple stuff, hey, I do want to run a timer here, okay? Yeah, I want to create a app level behavior that is a counter per seconds, or yeah, something like that, you know. And you can define that. So for example, which is something that it does here, right? And part of the exercise here, like this. So I can now extract this piece of information, this logic, into a particular file that I can later on use that, not in this web app, but also in other web applications. That's one of the powerful things of this idea behind that. The problem that it solves, which is, let's go to define now these app level behaviors, that it can be reusable across other different apps. That's powerful. So one of them is, hey, I do want to create a custom hook that to keep track of the mouse move, right? Or that click or that generate a new or that star and pause, that start, pause, or reset a timer, for example, or that allow me to detect when certain elements in the DOM, or allow me to detect when the viewport path through certain elements in the DOM, right? So we have the DOM and I'm in the viewport. So when it reaches to this point, I want to now notify you using the observer API. So that's very interesting, right? Or you say, hey, use is on screen. So the powerful stuff of understanding this, or even in the toggle, in the digital clock exercise here, we will click a button to toggle clock off and on. But the idea of this is that when you, correction, solution with restrict. Okay, but the idea of this custom hooks is that it allows us these app level behaviors. And one of those app level behaviors that we always have to do in the front end is to call that data, right? Or do this data fetching transferring. So finally, of what I really care in today's video, okay, to make a quick recap of the history of data fetching on the web. First, we did that, we still can do that using the HTML form. This was the way how you did this in 1993. By providing is an action, which is the route of the server that you want to send data or read from that. The method, which is the HTTP verb, that describe to the server, hey, what these actions is all about. You want to read data using get, or you want to submit data using a post, or update data using put, or delete some data. Right, this is the arithmetic, the basic operation here. And And in 1999, Microsoft software and Microsoft, a bunch of smart, very very smart software engineers, they have these particular problems of how can asynchronously wait for some data to be completed in JavaScript. So you can think of this like uh, when you go out and buy a pizza in the place. So you walk to the counter, you ask to the counter to what kind of pizza do you want to. It tells you, hey, you want a pepperoni with pineapples. I don't know. You like pineapples. Who am I to judge? It tells you, hey, this is what there will be $7.99. You say, okay, good, right? So it gives you now a recipe that represent is this promise like of your eventual pizza. So you don't have that pizza. You just have now a recipe of that, which is one of the problems that they have. It's like, how can I represent this process? So it turns out that they develop several techniques known as the Ajax programming that involve is an object that represent is how data is transferred between the client and a server, which is the XML HTTP request. Okay, that's quite interesting to dive into that. And as the year progressed, it turns out that showed quite effective at that point. But there are several resources that the web need to fetch. So, for example, is script tags, image tags, also CSS cursor, and they need to have a way to make a simple operation for fetching resource, and that include is fetching resource in JavaScript. That's what we have now, the fetch API. So it makes a ton of sense. You can read of the spec, you can read of the fetch API spec and the XML HTTP request spec and understand that and to say, oh, I know what the challenge was back then and what it aims to solve here. So because now we are writing applications using React, this framework, okay, and most of the time we have this data fetching situations when you somehow need to fetch data when the component is mounted, or fetch data based on an event, right? So in these two scenarios, on the first one, this is when now things in the React sense can become quite cumbersome. Why? Well, to make it short, we have now is several libraries that allow us to do that in React. For example, React Apollo Query, React Query, SWR, also is Apollo Client, right? But all of these libraries, what they aims to solve is this specific data fetching behavior that we need to have in our application, right? So this is why we need some prerequisites to learn about, well, what I mentioned before, the little bit of history, the HTTP verbs, the HTTP code to understand when the server responds. 100 series is for information, 200 is for success, 300 is for redirections, 400 is for client errors, and 500 errors are for servers errors. So HTTP error code. like that, you know. So exactly. So basically is is this, right? 100 series is for information, 200 series is for success, as you can read here. 300 is for redirections, 400 are for client errors, and 500 is for server errors. Got it. So, and also understanding what a promise is in JavaScript and the async and await syntax here. So I went through this, okay? To understand is fetching data on an event, all right? There is no mystery behind that. And the other is fetching data on mount. This is when you want to rely on, you can create your own query or you can create your own logic in React, but it turns out that it's quite, it's a surprisingly turny problem, right? When you want to pull data on the initial view, and when something happens, for example, when you switch tab and it goes back, you want to update that. So this is not a trivial problem here, right? You also want to catch this response so we can reuse that across our entire app and make that and make sure that our data doesn't grow stale here by having some revalidation mechanism. This is why we have now this SWR, okay, which is part of the HTTP catching strategy that say, hey, let's go to now stale while revalidate. That's what it stands for. And they say, hey, when something happens, whether it is when you change the tab from one place or another, or when the component is mounted initially, I'm gonna run now this script. I'm gonna fetch that data. So you do this and then you go back. As you can see, it actually changed that accordingly. So that's very, very.
So I recognize there's a lot going on here, but fear not, we're going to walk through how all of this works. The first thing on line 2 is we are importing this custom hook called useSWR from the SWR library. And I'm so excited about custom hooks because they make things like this possible. It's not only useful for ourselves, right? If we have some bit of logic that we've written, we can wrap it up in a custom hook and then reuse it. We can also grab third-party custom hooks, right? Custom hooks that other people have written. And in this case, I expect the team has spent hundreds, if not thousands of hours building and optimizing and battle testing this hook. And so it's really cool that we get to import it and use it in our code like this. And the way it works is that we call the useSWR hook and we give it two things. The first thing is a key. This is meant to be some sort of unique identifier for the particular API route that we want to make a request to. Unless you're using GraphQL or doing something kind of funky, you want this to be the endpoint itself, right? The location that you want to make the network request to. The second thing we give it is a fetcher function. And here we hit probably the biggest misconception around libraries like this. I think people think that if you use a tool like SWR or React Query, that it totally abstracts over the data fetching process and it manages all of this stuff for you. When in fact, as you can see, we're doing a lot of the same work we were doing in the previous lesson when we were making a request without any sort of library. Tools like SWR are meant to be agnostic when it comes to the actual process of fetching data over a network. So you can use Fetch or Axios or any tool that you like for actually making the request. The difference is that we're packaging that stuff up in a function and we're giving this function to the library. And so use SWR.
All right. Yeah, that's might be quite cumbersome here to throw a new error here at that moment, like throw JSON. Something goes wrong here. It is rendering this, right? We say loading. Say something goes wrong. You can also remove it and say, hey, just make that HTTP request and give me the value, or I can simulate some error here, right? So so on the exercise here, suppose we are building a, yeah, I already did this, and how useful it for us to kind of wing through this. And some of the async effect gotchas here. Suppose we want to fetch some data on mount and we don't want to use SWR. We'll make a fetch request inside a useEffect hook, and using the async await syntax, most developer will try to do something like this. Exactly. This is if you want to go with your own data fetching solution in React. So in order to use a wait keyword, we need to be way within the async function. It seems logical that we make sure our effect callback async, but unfortunately this doesn't work, right? And this doesn't work because remember that at the end of the day, you are passing now a function to React to say, hey, this is what I want you to run here. And because your function is gonna get called for you, so you are not calling that function. This is what it makes sense for us to provide now an async function here, because it's up to the React to call our function for us, right? Instead of us having to define and say, hey, this one. But if you analyze this for a second, right? If you say, hey, okay, let's gonna do this, right? If I say, hey, for some reason, all right, I do want to do this, right? And get rid of this, yada, 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 and the, so what's happening here is you say, all right, I'm gonna give you, so I'm gonna give you now is a function, asynchronous function that is going to return now is the cleanup function. But this asynchronous nature, which is a function that is gonna be a call out of sync, because you can, the whole point of this is you can now so the point of this async function is that you can stop the execution of this function at some point. The point is await here, right? And then when you have that data available, right, the event loop is gonna get that data from the microtask queue that is injected by the browser, and then pass to the call stack to be evaluated and say, hey, now this is the value that you are awaiting, that you await for, right? And continue the evaluation of this. So this is an asynchronous operation. And this asynchronous nature, right? You can await here some counts, await my API here. If effect doesn't need props or state, learn more about need props or state. For example, like this, on the rules of data fetching. So if we read about this and say, hey, effects callbacks are synchronous to provide race conditions. Put the async inside here. So, okay, you can learn more about this race conditions. How can I do data fetching with hooks? Oh, and they, okay. Got it. And they go all the way down to that, right? Okay. And then you fetch the data. And here is how you can now do is this data erasing. Ignore false, right? So if you run these functions first, yeah, so if you run this function first, what you're saying is, hey, in the React context, if this is false, right, set the data. So use this data. So what you're doing with ignore is like revalidating that to prevent any race conditions here. Okay. In addition to the cryptic error message, we also see the following warning in the console. Warning, useEffect must not return anything beside a function, which is used for cleanup. It looks like you wrote useEffect async or return a promise. Yeah, it looked like you wrote useEffect async or return a promise. Instead, write the async function inside of the effect. So the TLDR is that React on these hooks need you to pass a callback, a synchronous callback, not an asynchronous callback. This is based off any internal behavior like this, right? So essentially we move all of our effect logic into an async functions. I like to use the generic name like run effect instead of a specific name like fetch temperature to make it clear that we're moving everything related to that to the effect into this function. In our effect has a cleanup function, which is this, the cleanup logic, and the cleanup logic should not be included in the run effect. To be clear, we don't run into this issue at all when we use a data fetching library like SWR. This is one of the many problems that those tools solve for us. But I want to cover this anyway because not everyone uses data fetching libraries. And even if you do, there may still cases where you want to await some sort of async operations unrelated to data fetching. Why async effect callbacks aren't allowed? It might seem silly to create and immediately invoke an async functions. Why aren't we allowed to pass an async function directly to the use effect? The first thing to understand about async function is that they always return a promise. Exactly. And remember, use effect require you to pass a callback, a synchronous callback. So this quick example function doesn't actually return the number 5. Exactly. Right? It returns you a promise. So this is true for all async functions, even one that don't await anything. This is important because React expects us to return the cleanup function, not a promise. In other words, is another function. Consider an effect like this. When React run our effect, we hand it a cleanup function here. And React will invoke this cleanup function when the dependency changes and when the components amount. Now let's suppose we have some async work to do in the effects. So for example, like this, right? Even though we are returning a function here, it is actually exactly, even though that we are returning a function here, the way how this async await works is going to return a promise. So when React runs this effect, it doesn't receive a cleanup function, it receives a promise. And what happens if the component amounts while the long running process is running? React can do any cleanup because we haven't yet handed React the cleanup function. To avoid sticky situations like this, the React team decide that effect callbacks can be asynchronous functions. It will open too many cans of worms. Instead, we can wrap our async logic up in an async function, and that way React receives the cleanup functions immediately, right? The TLDR is that this is what Reacts expect. This is what this function expect. Just follow the contract here. Just follows the contract. Just follows the contract. So in the next video, I will go over the memoization techniques, right? But that'll be all for this video. Take care. Bye bye.